Hello everyone, welcome back to Civil Tech. Welcome back to my YouTube channel. So guys, today we have a geotechnics question. It's an HND past question, I think HND 2024. So guys, this is the question. So they say a 7.0 meters high retaining wall has a horizontal backfill of dry sand. Take note, it is a dry sand. So it is a cohesionless soil with unit weight of 17.2 kilonewton per cubic meter and an angle of internal friction theta equals to 32 degrees. The wall is cast in place concrete with a friction angle S equals to 20 degrees. Ignoring the effect of the passive pressure upon the toe of the footing, find the magnitude of the active earth force. So guys, take note of the question they want us to solve. So they say find the magnitude of the active earth force upon a length of wall equal to 3.5 meters, assuming Rankins conditions. So we are going to use Rankins method to analyze this our retaining wall. So guys, if we are to model a retaining wall, if you are to have an idea of what we are seeing, I'm going to produce a retaining wall of such, and then we are going to use to solve. Stay tuned. Please, if you're just coming in for your first time, welcome to Civil Tech. Please don't forget to like, subscribe and share for more videos. So they gave us the unit weight of our sand. They gave us unit weight for our sand to be 17.2 kilonewton per cubic meters. They gave us the angle of internal friction to be 32 degrees and the angle of friction to be 20 degrees. Yeah, and they say we are working with the length of, they gave us the length of 3.5 meters. So guys, this is our retaining wall, our retaining structure. So this is how it looks like. This is the backfill material, which is sand. It is a cohesionless soil. This is the retaining wall. So using Rankins method, the first thing we are going to do is to calculate the coefficient of active earth pressure, which is known as Ka. Ka is the coefficient of active earth pressure on our retaining wall. So it is given by the formula 1 minus sine theta over 1 plus sine theta. So guys, please take note, this is a cohesionless soil. This is a cohesionless soil. So our coefficient of active earth pressure will be equal to, if you now substitute our values, so our angle of internal friction between the sand and the retaining wall was 32 degrees divided by 1 plus sine of 32 degrees. So we are going to punch together. So we are going to have 1 minus sine of 32 divided by 1 plus the sine of 32. Hope we have the correct digit. Yeah. So we have our coefficient of active earth pressure to be 0. So our Ka is equal to 0.307. So this is the value we are going to use for our coefficient of active earth pressure to continue with our exercise. So the next thing we are supposed to do is we are supposed to calculate the active earth pressure. So the active earth pressure is given by the unit weight of sand times, we have the unit weight of sand times the height of the retaining wall square, or the height of the retaining structure squared, times the coefficient of active earth pressure. So if we are multiplying by half, so we can divide by half. So our active earth pressure is given by, we have 17.2. This 17.2 is as a result of the unit weight of the sand they gave us. So times the height. The height of the retaining wall was 7. So if we come back to this our retaining wall, we can label this one to be 7 meters. Yeah, so 7 square is 49 times coefficient of active air pressure, which we just calculated, and it gave us 0.307. 0.307. Don't forget to put it over 2. So coefficient of active air pressure is equal to, we are going to calculate together. So we have 17.2 times 7 square is 49, because 49 is a perfect square. It is obtained by multiplying 7 by itself. So that's why we say 49 is a perfect square. So times 49 times times 0.307 is equal to, syntax error, sorry. We have 17.2 times 49 times 0.307 is equal to 258 divided by 2. So we have our active air pressure to be 129.3698. If we want to be more precise, we can take the decimal places behind. So thank you. So now to calculate the magnitude of the force, so let's go back to the equation. What they want us to calculate is find the magnitude of the active air force upon a length of wall equal to 3.5 meters, assuming Rankine's condition. So take note the magnitude of the active air force. So we are going to say the magnitude of the active air force. The magnitude of the active air force is equals to the active air pressure times the length. So magnitude of the active air force is equals to 129.3698. So I am taking these values to be precise with my calculations. So times, you can either round down or round up depending on you, times the length. So we're working, they gave us a length of 3.5 meters. So yeah, so Fm is equal to, Fm here simply means the magnitude of the active air force. I decided to abbreviate it as Fm. So when solving, you too can abbreviate it, whatever abbreviation you give it is acceptable. So let's calculate together to have the magnitude of the active air force. So we are going to have 129.3698 times, are we together? Yeah, times 3.5. We are going to obtain 452.7943. So the unit of force is kilonewton, so we are going to work with kilonewton. So here we have the magnitude of our active air force to be 452.7943. Please don't forget to subscribe, like and share for more videos. If you have any other questions, you can ask. Thanks very much.